Moving over the go sub command, which would take us to the subroutine for the lockout system, we get to the 16-bit binary counter routine, where the hits that you received, which is added up here, will be calculated, and for each number it could be, a different set of lights will be lit up. I'm sure there's an easier way of putting it in the program, but I have not found that or made it yet. So I will get onto that, but I don't know if I'll be able to do it. In any case, each system will either bring an LED to a digital high state and turn them on, or digital low state and turn them off. And way down here at the bottom is the old version with the frequency variable that I hadn't used, and this was supposed to act as the auditory readout command, where the frequency that the tone would be produced at would increase by 100 Hertz every time the cycle went through all 16 bits. But I decided to put in the tactile switch and add more code so that you can hear all the hits you've taken. Okay, moving on to the lockout code in its own subroutine. We have a repeated section where all the LEDs will be turned on, a tone will be played, and then all LEDs will be turned off, and a reset debouncing code will be used, another tone, and then finally another debounce code. That's repeated twice to produce the LED and sound alarm when hit, and then the LED countdown occurs, where one of the 3 LEDs will be turned on, pause for a third of a second, and then turn off for a third of a second. This will be used for 3 of the LEDs, and then finally another debounce code will be used to prevent multiple triggers from happening. Once that's done, it returns to where it was called from, and the loop continues. Starting with asking if there's any contact with the tactile switch. Then it goes down here and buzzes a short tone in between the statements. And then if there's any trigger from the 555 timer chip, it will debounce the trigger, add one to the hits, go through that lockout alarm code, and then finally go to the 8-bit, the 16-bit binary counter with the LEDs, and repeats the loop over and over until you stop the microcontroller or you lose power. I hope you enjoy this, and I'll answer any questions if you have them about the programming.